Hello everyone. So in this video we are going to discuss about decryption of Hill cipher. So this video is about Hill cipher decryption process. So as I already told you that how we decrypt using Hill cipher. So it is P K inverse mod 26. So it means first we need to calculate the inverse of matrix K. This is K inverse. So K is, we will take the same key which we have done for used for encryption. So it is 17, 21, 2, 17, 18, 2, 5, 21 and 19. And the operation is obviously mod 26 operation. So K inverse, if we want to calculate inverse of any matrix, so that K inverse is going to be 1 upon determinant of K. This is formula for K inverse, 1 upon determinant of K and adjoint of K. So I suppose that all of you know how to calculate determinant of K and adjoint of A, but just because we are discussing the decryption, I will show you with the help of an example. So if we want to calculate determinant of this matrix K, like write it in the determinant form 17, 21, 2, 17, 18, 2, 5, 21 and 19. And remember that whatever we are doing, determinant calculation, multiplication matrix, or whatever operation we are doing here, that all are going to be mod 26 operation. So always keep this in mind. So when we calculate determinant of this, it is going to be 17. Then we will leave this column, first column and first row, and this will be 18 into 19 minus 21 into 2. Similarly, the second row, and this now plus minus and plus. So this is going to be minus. Now we will leave first row and second column, and it is going to be 21 into 19 minus 21 into 2. And then plus 5. We will leave the third column in first row, and then it is going to be 21 into 2 minus 18 into 2. So let's write it. It is going to be 17. 18 into 19, which is 342 minus 42. Similarly 17 and 21 into 19, which is 399, and it is again 42. And plus 5, this is 42 minus 36. 42 minus 36. So it will be 17 into 300. It will be minus 17 into 357. And it is going to be 5 into 6. So here it is, let's take 17 as common. So it will be 300 minus 357, which minus 30. Sorry, it is plus 30. So here it is going to be 17 into minus 57 plus 30. So it is going to be minus 939. Sorry, minus 969 plus 30. So it comes out to be minus 939, and it is mod 26 operation. So when we do mod 26 operation here, it is minus 939 mod 26. So when we do mod 26 operation, it is minus 3 mod 26. So first thing is, we always do mod 26 operation for Hill cipher, whether it is matrix multiplication, calculation of determinant, calculation of adjoint. For every operation we are going to consider that operation for mod 26. Now second thing is, we are considering only positive number. So how we can convert this minus 3 into positive number? We will add 26 to this. So minus 23 plus 26 mod 23. So mod 26. So it comes out to be 23 mod 26. So the value of determinant k is comes out to be 23 mod 26. Now the thing is, when we say that we need to calculate 1 upon determinant k, it means we need to calculate determinant k inverse, adjoint k. So how we calculate this determinant k inverse? This k inverse also we should calculate under mod 26 operation. So when you calculate, so what does it mean when we calculate? So it means 23 into 23 inverse mod 26 comes out to be 1. And we know many algorithm how we can calculate inverse under mod 26 operation. So you can use any one of them, and this comes out to be, if you calculate 23 inverse mod 26, it comes out to be 17. So the value of determinant k inverse here is 17. So what we have done up to now, we simply write how we can calculate k inverse. K inverse can be calculated 1 upon determinant k and adjoint of k. So we first find out the value of determinant k, which comes out to be negative number minus 3, and this determinant k also we calculate under mod 26 operation. So if we want to find a positive equivalent to this minus 3 under mod 26 operation, we need to just add 26 to this number. Then we get 23. Now because it is 1 upon determinant k, it means we need to calculate inverse of this number, whatever is determinant k. So it is 23, and this is under mod 26 operation. So we need to calculate inverse also under mod 26 operation. And we have discussed so many algorithms to calculate, like extended Euclid algorithm. You can calculate inverse using extended Euclid algorithm also, and that will comes out to be 17. So up to now we have done this calculation. Now let's come to how we can calculate adjoint of k. So here we need to calculate adjoint of k. So first I will write k, which is 17, 21. Okay, just a minute. For calculating adjoint of k, let me write k first. K is equal to 17, 21, 2, 17, 18, 2, 5, 21, 19. This is matrix k. Now when we calculate this adjoint of k, so we need to calculate cofactor of every number. So how we can calculate cofactor for every number? Let's say we need to calculate cofactor for this 17. So what we will do, we will leave this column and this row, and we will calculate 18 into 19 minus 21 into 2, which is 42. Similarly, if we need to calculate cofactor for this number, we will leave this column, second column and first row, and it will be 21 into 19 minus 21 into 2, which comes out to be 42. Similarly for 5, we will leave that column and first row. It will be 21 into 2, which is 42, minus 18 into 2, which is 36. Then let's come to this number 21. We will leave this second row and first column, and it will be 17 into 9. It will be second row and first column. So it will be 17 into 19 minus 5 into 2, which is 10. Then for 18, second column, second row. So again it will be 17 into 19 minus 17 into 19 minus 5 into 2, which is 10. And then we will, for this 21, we will leave third column and second row. So it will be 17 into 17 minus 17 into 17, which comes out to be 0. Now let's calculate the cofactor for 2. Leave the first column and third row. So it will be 17 into 21 minus 18 into 5, which is 90. Similarly for this 2, second column and third row. So it is 17 into 21 minus, it is second row, second column and third row, 17 into 21 minus 21 into 5, which is 105. And the last one is third row and third column. So it will be 17 into 18 minus 17 into 21. This is for adjoint. And also we will do the signs will be alternate, like plus, this will be plus, this will be minus, again this will be plus, this will be minus, this will be plus, this will be minus. However, for 0 it doesn't matter. Then it will be plus, it will be minus, and it will be plus. Now let's do the calculations. So when we calculate the first one, 18 into 19 minus 42, it comes out to be 300. Similarly, 21 into 19 minus 42, it comes out to be minus 357. This comes out to be 6, which is plus. Then 17 into 19 minus 10, it comes out to be minus 313. This comes out to be plus 313. This is a 0. Then this comes out to be 267. The next one is minus 252. And the last one is minus 51. And this is mod 26 operation. This is for mod 26. So when we calculate this for mod 26, so it means we are going to divide each and every element, every cell of this adjoint with 26. So for first, that 300, remainder will be 14. For minus 357, remainder will be minus 1. For 267, okay, sorry. So when we find this, just a minute. So after doing this, how we calculate the adjoint? We just reverse, we just find transpose of this. First we calculate, first step is calculate cofactors. And second step is calculate transpose of matrix. Transpose of cofactors. So when we calculate transpose of this matrix, it comes out to be 300 minus 357 and 6. Then it comes out to be minus 313 and 313 and 0. Then it comes out to be 267 minus 252 and minus 51. And it is a mod 26 operation. It is a mod 26 operation. So when we divide each and every element of this matrix with 26, so what will be the remainder? For 300 it will be 14. For minus 313 it will be minus 1. For 267 it will be 7. For minus 357 it is going to be minus 19. Then it is going to be 1. Then again it is going to be minus 18. Then 6. Then 0 and minus 25. Again this is a mod 26 operation, and because this is a mod 26 operation, we are not going to consider this is minus 19. This is minus 19. And because this is a mod 26 operation and we are only considering the positive number, we will convert these negative numbers into the positive. How we can do that? We can convert it using plus by adding 26 to each and every number. So let me write it how we can do that. Like for example, the first one will be 14 because it is 14. Then minus 1, when we add plus 1, it comes out to be 25. Then 7 will be 7. Then minus 19 and we add 26, so it comes out to be 7. Then 1 will be 1. Again minus 18, when we add 26, it comes out to be 8. Then 6 and 0 and minus 26, it comes out to be 1. Again this is a mod 26 operation. So this is a complete, like we can say that this is adjoint of K. Now how we can find K inverse? Like here the K inverse is going to be this one. Determinant of K and adjoint of K. Determinant of K and adjoint of K. So just to find the k inverse, we are going to multiply determinant of k, which is 17, with adjoint of k, which is 14, 7, 6, 25, 1 and 0, 7, 8 and 1. And it will be like 17 into 14, then 25 into 17, then 17 into 7, which is 119, and then 17 into 7 again, which is 119, 17 into 1, which is 17, 17 into 8, and then 17 into 6, which is 102, then 0, then 17 into 1, which is 17. All this is mod 26. So let me write 17 into 14, which is 238, and then 119, then 102, 25 into 17, which is 425, then it is 17, then it is 0, then 119, then 17 into 8 comes out to be 136, then 17, and it is mod 26 operation. So when we apply mod 26 to this k inverse, this matrix, it is going to be 4, 9, 15, then 15, 17, 6, then 24, 0, 17. So what is this k? This is now k inverse. If you want to verify this k inverse, you can verify it. So then this k into k inverse should be an identity matrix. It comes out to be 1, 0, 0, 0, 1, 1, 0, 1, 0 and 0, 0, 1. So if you want to verify that your k, that whatever k inverse you calculate is correct or not, you can verify with this operation. So up to now we have calculated k inverse. What we have to do now? We have to we have ciphertext C and we have k inverse. So using this C k inverse mod 26, we can find our plain text. So let me do it for the first, which was, if you remember, or you can refer the previous video, the first 3 letter for the ciphertext was RRL. So R is 17 and L is 14. So what we can do? We can use this ciphertext with the k inverse, and k inverse is 4, 9, 5, 15, 17, 6, so this is 4, 9, 5, 15, 17, 6 and 24, 0 and 17. So now let's again do this matrix multiplication. So it is going to be 17 into 4 plus 17 into 15 plus 14 into 24. The second one is going to be 17 into 9 plus 17 into 17 plus 14 into 0. So I'm not writing it because it is 0. So next one is, let me check for L. L is 11, not 14. Sorry, L is 11. So if L is 11, so this is going to be 11, and wherever I write 14, it comes out, it is 11. So 11 into 0. Now let's do this one. This is 11. This is 11. 17 into 5 plus 17 into 6 plus 11 into 17. This is 17 into 6 plus 11 into 17, and it is mod 26. So let me write directly what comes out to be. It comes out to be 587. It comes out to be 442. It comes out to be 544. And then we can do mod 26. So when we divide 587 with 26, the remainder will be 0, 15. Here for 442, the remainder will be 0. And for 554, the remainder will be 24. So this 15 is P, this 0 is A, and 24 is Y. So if you remember, the first word was pay. So similarly, you can do it, verify it for all other ciphertext. So we used in encryption, so that you can practice how we can decrypt using Hill cipher. So I'm going to just discuss it one more time, just a quick revision for this. Let me do that. So decryption process says that K inverse. So for first time, I mean, like, for first we need to calculate K inverse. So first thing you need to keep in mind, whatever you are doing here, whatever calculations you are doing, all calculations are under mod 26 operation. So how we can calculate the inverse of a matrix? The inverse of a matrix can be defined with 1 upon determinant of that matrix into adjoint of that matrix. So here we did determinant of that matrix, which comes out to be a negative number. So one more thing you need to keep in mind, that we are working only on the positive numbers. We don't work on the negative number, because we do not have any any matching alphabet for a negative number. So we need to convert this negative number into the positive one. That how can you do that? You can simply add 26 to that negative number and you are going to find the positive one. So we find 23, and then because it is 1 upon determinant of K, it means because we are using mod 26 operation here also, so we need to find out determinant K inverse. So determinant K inverse under mod 26, we have many methods like extended Euclidean algorithm and other algorithms. So you can find it using extended Euclidean algorithm, and it comes out to be 17. So determinant K inverse become 17. Now the second thing is how we can find, how we can find adjoint of K. So to find adjoint of K, first we need to calculate cofactors of all the numbers of this matrix K, and then we need to calculate transpose of cofactor matrix. So how to calculate cofactor? If we want to calculate cofactor for 17, we need to skip this row, the column and row of 17, and then we can multiply minus this. So likewise I calculate cofactors. The one more thing, it goes alternatively plus minus plus minus plus minus plus minus plus. So once we calculate the cofactors, we find transpose of this matrix. Transpose means we converted rows into columns and columns into rows, and this is again a mod 26 operation. So it comes out to be this. Again we have some, because we have some negative numbers, so we need to convert all those negative numbers into the positive one by adding 26. So this comes out to be adjoint of K. So if you need to calculate K inverse, that will be determinant K inverse into adjoint of K. So we multiply it and we find this is K inverse. How you can verify? If you multiply any matrix with its inverse, you will get an identity matrix. So if you want to verify that whatever K inverse you have calculated, that is the correct inverse, so you need to you can verify that using this calculation. And the last one, we just try it for the first 3 alphabet of ciphertext letter, and we get the first 3 alphabet of plain text. As a practice, you can do it for rest all the plain text, rest all the ciphertext we obtained in the previous video. So this is about the Hill cipher. Next video we will be discussing some more other interesting ciphers. Thank you.